Okay, so question is, the task is, we want to multiply this using the distributive law. Well, distributive law tells me that this is equal to 2 times 4 minus 5i plus 3i times 4 minus 5i. This times this means this times this plus this times this. That's the distributive law. Distributive law isn't a bunch of loops. If you use the loops right, though, you can get away with it. Okay, insist on getting away with it, okay, but you're taking your own risk. Right? Okay, so here we got it. And then this is, well, we know we can multiply this. It's 2 times 4 is 8. 2 times minus 5 is 10. There's an I there. See what that means in a minute. Then it's not 3i. Well, I and then minus 15i squared, right? Okay. Well, I'm going to give you, and of course I would combine. Okay, we'll go ahead and do this. Okay. Well, let's back up a second. Okay. Solve this equation. And go ahead and use a quadratic formula. It's not going to factor. Solve the equation, see what you get. Okay, did pretty well with it. We get x equals -2 plus or minus the square root of, well, 2 squared is 4, and 4 times 4 is 16. So we're going to get a -12 there. I think everybody got that. And that's over 2. Okay. So what's the square root of -12? That'd be half -12, it's a square root. 4, what's 4 times 4? 16, right?
-6, but
What? No, no, -6 times -6 is 36, right? What times what is -12? Okay, well, in the first place, square root of -12. -12 is 4 times 3, right? 4 times -3. And if you got the square root of 4 times 3, it's the same as the square root of 4 times the square root of -3. Why did I do that? I did that because now I can say that's -2 plus or minus the square root of 2 times -3 over 2. Okay. Now, square root of a negative number. Well, square root of a number, square root of 25 is, what's square root of 25? 5. And why is it 5? Because 5 times 5 is 25, right? There's no number, no real number that you can multiply by itself to get a negative. Okay? What's the square root of -25? You want to say it's -5, that's the first thing people think of. But what's -5 times -5? It's not negative. Okay? Can't. There's no real number that is the square root of a negative. So what we do is we say, well, that's -2 plus or minus 2 times the square root of 3. Because we, square root of 3, we don't know what it is, but it exists. There's a number we can multiply. If you multiply 1.7 by itself, you get 2.89, a little less than 3. Multiply 1.8 by itself, you get 3.24. So it's the square root of 3 somewhere between 1.7 and 1.8. he can narrow that down and you keep narrowing it down. And eventually you're gonna get to like 1.732. I don't know what comes after that. But we had to know that back in the day because we didn't have calculators. And square root of 3 comes up all the time. Okay, square root of 2, square root of 3, anyhow. So that's just how I know it. I didn't calculate it. I know how to calculate it. There's an algorithm. And we always use Taylor series, but okay, so that's just digression there. So we can write it like this. Well, I want to write I for the square root of -1. I said it can't be a real number. Okay, it's an imaginary number, and it's the basic imaginary number. The square root of -1 is I. Okay, so this I that I wrote here is the square root of -1. So if I is a square root of -1, what's I squared? Write it down. I squared equals square root of -1 squared, right? And tell me what that would be. Okay, now, I ask people to write down what's I squared. Well, it's the square root of -1 squared, right? What do you get if you square the square root of a number? You get the number. And the square of the square root of 25 is 25. The square root of 25 is 5 squared, okay? If you square the square root of -1, you get -1. Now, somebody said, well, if you square a number, get a positive. So there's a positive number and negative number. That's true for real numbers. Okay, but this isn't a real number, it's an imaginary number, and it's not negative. There's no negative in front of the square root of -1. Okay. I is a square root of -1. So I squared is -1. Now, given that I squared is -1, can you simplify this? This is the expression we want to be simplifying. Okay, this is already done. So we want to simplify this using the fact that I squared is -1. Okay. Well, it's easy to do. Get this, right? Yeah, that, not sure, something happened between this step and this step in a couple of places, but that gives us 8 plus 2i plus 15. Okay. And 8 and 15 makes 23. And then that's times 2 plus 2i. Because 2i can't be added to a real number. An imaginary number can't be added to a real number. They're different things. Okay. So what it comes down to is, with a little practice, it's really easy to multiply two complex numbers. These are called complex numbers. They're a sum of a real number and an imaginary number. Okay, you're going to see that. Look at the videos when you encounter it in your pre-calculus class. Now, I don't have an assignment on this for this class because it's pretty straightforward. People usually don't have a lot of trouble with it. But I do have an assignment for it in pre-calculus class, which was originally due today, and I realized we hadn't gone over it. Someone emailed me on it. Thank you. And I pushed the assignment back a little bit. Okay, that's how you multiply complex numbers. Adding and subtracting is real easy. Multiplying is not difficult if you use a distributive law and keep your wits about you, okay? And don't skip steps. Write it out this way. Try to write it out like this, okay? Boom, 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 boom. Now, if you want to divide two complex numbers, that's a little trickier. Let's say we want to divide this. Which means that we want to just get this as something plus some multiple of I. Okay, just in the simple form of a complex number. Do this. Now, can you simplify that? Can you multiply that up? Okay, now the step I'm not seeing anybody take. And we really have to understand this. Is multiplying two fractions. How do you multiply fractions? You multiply the numerators and you multiply the denominator. Now, some of you are doing that. But not necessarily right, because if you multiply the numerators, you're multiplying 2 plus 3i times 4 plus 5i, which is a whole lot like what I did here, except this was 4 minus 5i. And it doesn't matter what I did here, except that I used the distributive law at every step. So I've got to write this out as 2 times 4 plus 5i plus 3i times 4 plus 5i over 4 times 4 plus 5i minus 5i times 4 plus 5i. What we have to see when we see this expression is first, how do you multiply fractions? You multiply the numerators, you multiply the denominator. Then, how do we multiply this numerator, which is a complex number, times this numerator, which is a complex number? Well, it's a clear application of the distributive law. We're multiplying 2 plus 3i times 4 plus 5i. I kind of skipped a step there, and I'm thinking maybe I shouldn't have, but then we should write out that step. Then we continue. Okay. Now, when we multiply this out, we get 8 plus 10i plus 12i plus 15i squared over 16 plus 20i minus 20i minus 25i squared. Do we agree? Okay, I mean, that's what the distributive law tells us. We do it carefully, keep book track, you know, make sure our bookkeeping is correct. So that, and that's going to equal, well, 10i and 12i is 22i. So we can add those. We haven't done anything with the 8 or the 15i squared, although we could have done some of that 15i squared. Down here, what happens? Notice we have a 20i and a negative 20i. That's why we chose to use 4 plus 5i. 4 minus 5i times 4 plus 5i. That's gonna make this happen, okay? And that's 16 minus 25i squared. Now here's really all we have to know about I. I is the square root of -1, and I squared is -1. Make sure we understand the logic of this. So now we've got 8 plus 22i plus 15 times -1 over 16 minus 25 times -1. And this equals 8 plus 22i minus 15 divided by 16 plus 25. Then 8 minus 15 is -7. Denominator is just 41. Notice that we've got a denominator that's a real number now, not a complex number. Okay, we changed the form of the fraction to one where the denominator is a complex number, a real number. The complex denominator is real. Of course, that's changed the numerator because this is how we change denominators. Okay. So we chose to change the denominator to something that was just a real number. And now we can write this as -7 over 41. Plus 22 over 41 times I. Okay, just to repeat. Got to follow the rules and be very careful about our bookkeeping. Okay. And there are a lot of steps in simplifying this. Even a couple more steps in simplifying this. You got to be sure every step's right. Meaning every step has to be by a rule. And we have to use the distributive law carefully. We have to understand that I is the square root of -1, nothing else. I is I. Okay. And that stands for the square root of -1. So I squared has to be -1. That's it. Okay, so we use the distributive law also the idea that we can multiply any fraction by 1, and that's all we've done here. And 1 could be an expression over itself. We choose this expression to be what we call the complex conjugate of this expression. I'm going to let you read about that because I don't want to overwhelm you right here. There's terminology. Make sure you understand the terminology. Complex conjugate, you just change the sign of the I part. Simple idea. It's 4 minus 5i. You make this 4 plus 5i. Because when you do that, the i's go away. Now, so 3 things. Distributive law. I is I, nothing else. I squared is -1. And multiply by 1 in whatever form. Then you get this. Now, the whole point of this is here we have a complex number in standard form. It's just a real number plus a multiple of an imaginary number, a real multiple of the imaginary number. Okay, fine. And really just practice with distributive law and rules for fractions. And one little twist, these 2 rules here. Okay, and where does I come from? Well, it can come from solution of a quadratic equation. If you have a negative under that square root. You first gotta know this. Not that bad. If you practice it, okay? And make sure you're getting things right. This, you know, I'll go back and redo it, but turn out different stuff. Huh? That's bad. You're risking your life. Okay. Let's switch fast. Okay. Write it out. The idea, first idea is it's 2 times this plus 3i times this. Okay. Then it's this. You better do it. Did it right. Like I said, we'll live dangerously, okay, but your risk. And I'd rather you not think this. You know, you gotta leave it to you didn't know that. You wrote out the distributable. Okay, you're not living dangerously. And you're writing it up.
After we do this one, can we do a long division? One. I should go with that. Hard.
Yeah.
Man, I got a couple of them.
Yeah, we could talk more about long division if you want. If there's other stuff we're gonna be assigned that we need to talk about.
That's fine.
Yeah.
I mean, I've kind of passed most of this on in this class. The long division got me there at the end. I don't know, I wasn't really understanding. Kind of a pain,
Yeah,
like
Try-
the synthetic division part. I was starting to figure it out pretty good. And it was, you know,
But you don't understand synthetic division unless you understand long division.
Yeah, well, I was getting better. I was getting more correct answers with the synthetic division after I got so far in over math to really show you how to do that part.
Yeah, well, what it comes down to is, which basically they want you to do one of these tests.
Yeah.
They're gonna want you to do long divisions, they're gonna let you do small division.
There was one whole part on using the calculator for most of this stuff, except for that part. There's a lot of calculator work in his class.
Well,
To each his own.
well, a lot of people don't use calculator right when they teach it. He does. He knows,
Well-
he knows how to teach it.
I had to look up a lot of videos to teach myself, because it didn't really show you that much in the Myopen math. Really how to do it. Like it was, it showed you one video and it was like, man, they don't really take a whole lot. And I had to Google it and find more videos, how to do a scatter plot on there and finding the zeros on a graph. That one was helpful. That one was a lot of help.
My idea, you know what it means. Then it's easy to figure out if you're doing a calculator. If you're doing it in a calculator, it doesn't mean you know what it means.
Yeah.
Unless there are questions around it. It really. Okay. One. Okay. Now. Multiply this, okay? What's the rule for multiplying fractions? Multiply the numerator times the numerator and the denominator times the denominator, okay? I didn't write out that step a minute ago, and as I said a minute ago, probably should have, okay? Gonna write it out this time. That's 2x plus 3 multiplied by x squared plus 6 divided by 5x minus 1 multiplied by 2x minus 3. That's what it means, to multiply fractions. Numerator times numerator divided by denominator times denominator. Now, I've seen some people multiply this by this and multiply this by this and think they're done. Okay? Because skipping that step. So it's a mistake for me to skip that step. Okay? It's always this times all of this times all of this. Which means now you have to use a distributive law. You're going to write this numerator is 2x times x squared plus 6 plus 3 times x squared plus 6. And the denominator is 5x times 2x minus 3 minus 1 times 2x minus 3. You want to write out this stuff, and you want to write out this stuff. You don't write out both of those steps, you're not likely to get it right. At least not when you're starting. Okay, eventually, if you do 50 of these, then you can start skipping steps, because then it's ingrained. But you're not going to do 50 of them, so you better go back and do the steps. Okay. Be good if you could do 50 of them, but takes a lot of time. Then 2x times x squared is 2x cubed, 2x times 6 is 12x. 3 times x squared is 3x squared, 3 times 6 is 18. Then down here, we're going to get 10x squared minus 15x minus 2x plus 3. Now we can write things out. I'm going to choose to write this in the order of descending powers of x. I'm going to put the x squared term before the x term. So I'm going to write this as 2x cubed plus 3x squared plus 12x plus 18. In the denominator, I can add the x term and I get 10x squared minus 17x plus 3. And there, I've multiplied it. Now, it might be that I can factor this numerator. Probably not. Probably have to use long division. Try some negative values of x and see if I get these numbers to match up. Use the rational roots theorem, but we're not going to talk about that in here. Okay, let's talk about the really basic fundamentals. And then in your class, if that's to the extent that's covered, you're going to do it. Okay. Now the question is, how would I add these two fractions? Multiplying is easy if you just remember to use a distributive law. To add two fractions, what do I gotta have? We gotta have the same denominator. These don't have the same denominator. Well, if I want to get the same denominator, I'm going to do this. Okay. Denominator here is 2x minus 3, not 5x minus 1. So now I can see I've got my original fractions, you actually call them rational expressions. I'll call them functions. Okay, we got this, and we got this, right? And our denominators match. Okay. Denominator here is 5x minus 1 times 2x minus 3. Denominator here is 2x minus 3 times 5x minus 1. But it's the same delimitable denominator. Okay. So what we have now is 2x plus 3 times 2x minus 3 plus x squared plus 6 times 5x minus 1, all divided by this denominator, which I'll write as 2x minus 3 times 5x minus 1. I could write it in either order, this order or this order. Multiplication is commutative, so it's the same. And now we're home free. All we have to use is all we have to do is use the distributive law. Again, and again, and again, and again. And when you get into simplifying rational expressions and doing all this stuff, you're going to develop a great appreciation of why we've been emphasizing the distributive law. Greater than whatever appreciation you already have. Okay, well, we do this. And we write this as 2x times 2x minus 3 plus 3 times 2x minus 3. That takes care of this term. So this term here becomes this. And then it's plus x squared times 5x minus 1 plus 6 times 5x minus 1. So too much room to write this out. And all that is still over this. Now we get 2x times 2x is 4x squared minus 2x times negative 3 is minus 6x. And then I'm not going to read all these to you. It's pretty obvious what we're doing. Once you've written out the distributive law correctly in 2 steps, you're okay with this step here. Okay. Once you've written out this step, you're okay with the second step. Let's say that right. Okay, here we go. All this. Over this. Maybe I'll finish that out over here. I've got a little room. Okay. If I've done that accurately, you might ask, why don't I multiply this out? Okay. Well, the reason I don't multiply this out is one of these factors might actually be a factor of this numerator. So I want to have the denominator factored until I've factored the numerator, if possible, to make sure nothing matches up and divides out. Okay. Now I write out my terms. I've only got one x cubed term, that's 5x cubed. And then I've got a negative x squared and a 4x squared. I believe that gives me a 3x squared. And I've got a negative 6x and a 6x, which is 0 and a 30x. So all I've got out of that is 30x. Then I've got a minus 9 and a minus 6, which is negative 15. Over 2x minus 3 times 5x minus 4. And that'll be most likely my final answer. And it's legitimate to multiply this out at this stage. And then you might, in some circumstances, even want to do long division of what you get here into what you get here. It leaves that to your actual recalculus course. Okay. Not everybody is going to do that step. Okay, so the long division. What are we going to put here? We're going to put an x squared. Why? Because whatever we got up here has to multiply this to give us this. And the only way what we have up here is going to multiply this to give us this. So we got an x squared there. Okay. X squared has to be there. Now, the other way you can look at it is x divides into x cubed, x squared times. That works just fine. We get x cubed plus 3x squared. Now, please don't forget this step. Unless you're able to do these reliably. And you can put a little tiny sign up here for what you're really going to do when you subtract. Get over that before I think everybody understands that. So you're going to do negative 4x squared minus 3x squared is negative 7x squared. then you're gonna have a 7x. Okay, well, x goes into negative 7x squared. Negative 7x times. Another way of looking at it is, the only way we're gonna get. But we now, I'm maybe gonna say that, okay. So negative 7x times x gives us negative 7x squared, that's gonna match up. And then we're gonna have minus 21x. Now, new bookkeeping. And we're gonna get 28x out of this, and x is going to 28x 28 times. Yeah, it's gonna be 84. And we note that we subtract, and we get minus 93. I almost had room to do that, but I should have given myself more room. Okay, so we could then say the remainder minus 93. So now we can say that this divided by this equals x squared minus 7x plus 28 minus 93 over x plus 3. Assuming I did that right. Now let's check that. Let's multiply x plus 3 by x squared minus 7x plus 28 minus 93 over x plus 3. Well, use a distributive law and multiply that for me. See if I did it right or not. So some of you are skipping an important step, but I really rather you wouldn't skip, especially on this problem. Going to write out detail and one advantage to writing out the details is I see that I've got x plus 3 times negative 93 over x plus 3, right? What's that suggest? Probably suggests you want to cross these out, but I don't like crossing them out because people cross things out wrong. So I'm going to write this as x plus 3 is the same as x plus 3 over 1. I'm going to write it like this to make sure we understand that if I then change the order of multiplication of the denominators, x plus 3 matches up with x plus 3, and I'm left with negative 93. If you skip this step, you never see that. And there are going to be extra steps at the end that you might easily miss. Okay, so writing out the distributive law in all its glory detail. And you want to do that until you've done so much algebra that you know how to anticipate what might happen. And I hate to say it, it's unlikely you're ever going to do that much algebra in your life. Okay? So don't be skipping steps. Don't be taking shortcuts. Okay, so. X plus 3 times x squared is going to give us x cubed plus 3x squared. This is going to give us negative 7x squared minus 21x. This is going to give us 28x plus 84 minus 93. And of course, this give us negative 93. I believe that works. We got x cubed, 3x squared, negative 7x squared minus 4x squared, minus 21x and 28x is plus 7x. 84 minus 93 is minus 9. And this matches this. So this times this does equal this. That's what division means. Okay, now leave myself room. Write this one out. I'm not sure I have board please. I'd have to stop for a second. Let's see, yeah, this is okay, I got this place. Okay, so now we want to do x squared plus 3 divided into x cubed minus 4x squared plus 7x minus 5. So before I do that, I'm going to emphasize something. Okay. Could you graph this? Well, you can certainly graph this. It's just a parabola, axis of symmetry at 3/2 and 7/2, 3.5. Okay. And the vertex, well, you put 7/2 in for x, calculate y, so you know where the vertex is going to be. It opens up where it presents an x squared, so we can graph that parabola. Okay. It's a simple parabola with axis of symmetry, x equals 7/2 or 3.5. And it's up above the x-axis somewhat, because that 28 is going to raise it up pretty well. Okay. Somewhere maybe close to 10 or so. What about this thing? Well, we don't yet know how to graph this thing, but that's coming up. Okay. But it's going to turn out that this would have a graph that has a vertical asymptote when x equals 3, which is pretty close to 3.5. Which is going to distort the heck out of that poor parabola. Just giving you something to look forward to. Okay, now let's go back to this. Okay, this gets a little tricky. Okay, that x squared plus 3. Well, we're going to need x here because that's the only way we're going to get an x cubed when we multiply this by this. Just like over here, the only way we got an x cubed was multiplying this x squared by x plus 3. This x squared by the multiplying this x squared by this x, right? Okay, so we have to have x. Now, after that, it gets a little more complicated, but we have x, which is going to give us x cubed, and then it's going to be plus 3x. Well, I don't want to put the 3x underneath negative 4x squared. I want to put the 3x underneath an x to it. So we're going to put a plus 3x here. Now we're gonna subtract. Put my little minus sign there to remind myself. I'm gonna get negative 4x squared because there's nothing under negative 4x squared. We could put plus 0x squared. Okay. But there's nothing there, that's implicit. And then we have plus 4x. Well, now, what do? We have to multiply. Well, we're gonna need a negative 4 here, because negative 4 times x squared is going to give us negative 4x squared. Alternatively, x squared goes into negative 4x squared, negative 4 times. We're gonna have minus 4. That's gonna give us minus 4x squared minus 12. The minus 12 is gonna go underneath the 9. Gotta be careful, change our signs here, not change them, but indicate the real operation that we're gonna do. And now we're gonna have 4x here plus 3. So our remainder is 4x plus 3. So now we can say the x cubed minus 4x squared plus 7x minus 9 divided by x cubed plus 3x squared plus 3 equals x minus 4 plus x 4x plus 3 over x squared plus 3. Meaning that if I wanted to graph this quotient, I graph the x minus 4, that's just a straight line. Slope 1 through 0, negative 4. And then this one. Thing about this one is that the denominator is always positive and it's never 0. And when x gets big, this gets much smaller than this. So this term shrinks to 0. So it's going to be like the graph of the x minus 4 function plus some other function that does something. But when x gets big, whatever this does, then that doesn't change that x minus 4 graph by very much. Okay. Well, again, just something to look forward to. All right. Okay, just to do the scaling exercise on the sheet that I was just talking about. Here's 0, here's 1. Okay. If I divide this interval in half, what's my number here? No, don't say it, because you got the camera on. I think everybody knows that would be 1/2, right? If I cut this in half, I get 1/4. If I cut this interval in half, I get 1/8. And we notice that 1/8 and 1/8 makes 1/4. 1/4 and 1/4 makes 1/2. 1/2 and 1/2 makes 1. 8 of these, 1, 2, 3, 4, 5, 6, 7, 8. 8 of the 1/8 give us 1. So that's a number sense that people tend not to have. Okay, then we can go down to here. Dividing this in half, we can divide this and go from this. Yeah, I don't know what part of the chalk's going to write. We divide that in half, and we divide this in half. We don't have room to really label these. Okay, maybe we could label 1/16. Which would be here. This would be 1/32, 1/64. Divide that in half would be 1/148. Okay. Divide that 3 more times. and we get 1/1024. Okay. And that's a well-scaled graph. Okay. Now I can go with 512. This is still 0. Okay. This is an alternative scale. Instead of 1, we're going to say 512. If I cut 512 in half, what do I get? Well, it's easy to divide that by 2. I have 256. Divide that in half, I get 128. Divide that in half, I get 64. Divide that in half, well, I don't have room to be 8, that would be 32. Okay. So now if I want to locate, let's say, first 400 in this graph. Well, it's going to be between 256 and 512. A little more than halfway. I could add my 128 to 256 and get a number here. Okay. That's going to be 300. It's going to be 384. So here's 384. So 400 is going to be another thing I can do is I could say, okay, if I want to do these at tens, that's pretty close to 500. That's about 250. That's a little more than 100. So 100 ought to be maybe about here. 200 maybe here. 300 and 400 maybe in here and here. Okay, there are things I could do with that, but it's a way of scaling the graph. And it gets the idea of splitting graph, splitting the intervals in half so that you get nice intervals. Now, what you don't get is nice decimal numbers, nice round numbers. Okay. There's a way of keeping you honest if you want to do a well-scaled graph. There are also insights about numbers that are involved with that. So, understand what I just did more or less. Doesn't take long to do those first few minutes or stuff. Okay, well, I'm going to kind of dive into this. There's a problem on order of operations. Problem at the very bottom of the page asks you to scale the graph from -16 to 16. So it's, okay, well, that's the x-axis. Okay. Divide this interval in half. And of course, there's where 0 is, so now I know where my y-axis is. Then divide this interval in half. I get 8. Divide this one in half. I get 8. Divide in half again, I get 4. -8, -4 here. 2 here. -2 here. We do the same thing on the y-axis. And I'm going to subdivide here, get 8. Subdivide this, get 4. Subdivide this and get 2. Here I've got 8. Here I've got 4. And here I've got 2. Fortunately, I'm not going to need it. for this graph, is kind of obliterated by the zero I had there. Okay, now we want to graph what function. Graph g of x equals f of x plus 4 minus 4. Where f of x is, in this case, well, the problem reads the basic square and cubing, reciprocal square exponential functions are going to be respectively 1, 2, 3, 4, and 5. And the problem randomly selected number 1, which is your squaring function. Okay. Now, if I use this as a test problem, and I'm very likely would use it at least as part of the test bank, that would mean f of x is x squared. Okay. Well, now I could do f of x plus 4, which would be x plus 4 quantity squared minus 4. I could expand it and I could then figure out where the axis of symmetry is and everything, but I already know if I understand this graph. So on this scale, first of all, f of x equals x squared. It says use transformations. I'm going to use transformations. The x squared graph is going to have the point -2, 4 and 2, 4 and 0, 0 and 1, 1 and -1, 1 and 1/2, 1, 4, -1/2, 1, 4. So right here is a graph of x squared, kind of small on the scale 16. Now, how am I going to graph this? I'm going to take each point and move it over 4 units to the left and then down 4 units. That's what transformations tell me. I'm not going to re-explain transformations. So you're going to need to know how to use transformations. So f of x plus 4, every point moves 4 units to the left. So 4 units is this much here to here. So I got to move 4 units to the left, and move this point 4 units to the left, and move this point 4 units to the left. This point's going to go 4 units to the left. So is this one? Well, to get these points, when this moves 4 units to the left, it's going to end up. Oh, I went and screwed up this graph from the very start. I'm going to fix that. I treated this as if it was 1 and this as if it was 2, right? That's not good. So I made a mistake. Here, look at my x-axis. What's going on? Yeah, what about something? Here's 4, here's 2. Now here's 1 here, here's -1 here. So when I did my points, I just didn't do them very carefully. I'm going to have a point here. I'm going to have a point here. I have the origin down here. And I'm -1/2, 1 point like here, 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 and here. On this scale, this graph looks very narrow. Okay, now, as I said, transformations have replaced x by x plus 4. Which means I'm going to move all my points, 4 units to the left. Which is gonna move my this point over to here. This point over here. This point here. And it's gonna move these points as well. And I'm gonna end up things here, here, here. Here and here. So here's my f of x plus 4 graph. Now, I got a vertical shift of -4, so I got to move everything 4 units down. Where's the color that I want? Yep, can't find it, I'll use it. Okay. So moving 4 units downward. This point's at x coordinate 4. If we want, just a reminder, here's a line where x equals 4. So every point is going to have to go 4 units lower. That point's going to go down to there. This point's going to come down to here. This point will come all the way down to here. And this point will come down to here. This point will come down to here. I have points here, 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 here. Not very well drawn. But here's f of x plus 4 minus 4. Now, if you look at the next problem, go ahead and read the next problem and the next. Oh, forget it, it doesn't give you a solution yet. Okay. Matter of fact, we don't have a solution to any of these, but you should. And that's one of the bugs I've got to get out of the program. There's a little bit of code that I mistyped. Was that wrong? So let's look down at the 4th problem on the 2nd page. Just read that problem. Okay, now at this point, the solution to this problem is there. I thought it was going to be there and it wasn't. So I was going to comment on that, but we're going to skip down to another problem, which asks you to sketch 2 points on a graph of y versus x. Okay, it asks you something else too, but certainly everybody can sketch 2 points. The points are -6, -5, and 1, -1, -3. Okay, everybody can do that. Then we're supposed to construct a fundamental triangle for these points. It's been a while since I've asked you to do that. Everybody was doing it fine back when we did it. Not sure you've used one since then. Yeah, probably should have, but not sure you did. So you might need some review. Well, the point of this whole set of problems is review and to give you an idea what to expect. So the first thing in the solution tells you the hypotenuse of your fundamental triangle is going to be the line from one of the points to the other. So if you don't know how to do a fundamental triangle and you didn't know to connect them with a point, now you know. Read that instruction. Okay. Then it gives you step-by-step instructions of everything else. If you hadn't already drawn that hypotenuse, that's your signal to draw it. The first sentence is your signal to draw it. It says the hypotenuse is the line between the points. Certainly you can draw the line between the points. And I think you can do all the rest of it too with a little reminder. So it's a simple process. My point is, you need to do these actively, don't just read it. because you're gonna, unless you got a really good ability to visualize and hold things in your mind when you're visualizing them. At some point in reading the solution, you're gonna lose track. Draw it on a piece of paper, so you have something to look at. That's how you want to use these problems. Okay? And some of the later ones are more complicated. That was pretty simple. We use that one for an illustration. Okay, well, another problem, go down a little ways, gives you x equals 2, y equals -2, and if x equals 7, y equals -3. Find the average rate of change of y with respect to x on the interval, closed interval bracket 2, 7. That's the terminology that you're going to be familiar with in open math. It's exactly terminology they use. It's the problems that you've done, but the solution goes fairly extensively. It gives you the definition of the average rate of change. And it implicitly says, instead of on the interval 2, 7, it says from x equals 2 to x equals 7, the change in x is this and so forth. I believe you're going to connect that with the interval bracket 2, 7 bracket. And it's going to kind of reinforce all that terminology. Okay. That's my thinking on this. Again, if you've been through the problems and done the homework, it should serve as a good refresher, a good reminder of some of the subtleties and the way the problems are stated. Okay. Fundamental triangle and average rate of change. Be familiar with what I've written here. Run equals whatever, rise equals whatever. I'm not going to put numbers down. Slope is rise over run, that whole process. What's a run represent? This is X and this is Y. Run is change in X. So your rise is some calculation. And when you do this, you do like 7 minus 2 equals 5. Show the whole calculation as we've done. And then slope is rise over run and whatever that is. Okay. So rise is changing Y, run is changing X. And that's the average rate of change of Y. With respect to X. I include terminology, rate of change of what with respect to what. Because that's a really important idea that corresponds exactly to notation that you see early in a calculus course that you're not going to understand as well if you don't have this terminology, rate of change with respect to. And that also, you don't have that idea when you start, it's not going to develop as well when you take a calculus course. And when it becomes important in an application to know rate of change with respect to what, it'll be hard. Okay, so we include that terminology. It's not a difficult terminology. And we get it straight here, and we get it straight with this picture. Because again, this picture is real important for understanding derivatives, understanding what calculus is telling you. Otherwise, if you don't have this picture, that idea doesn't develop as well. And again, it's easy to get lost when you have to apply it. Okay, so there's a rationale for this whole picture and for stressing this whole picture. Okay, now I've asked everybody to read a problem that says, here are 2 points that get moved, okay? And it's fine when you're working at home. If you want to meticulously line off the graph with 100 labeled points, okay? But this problem simply says, okay, here are 2 points. So the first thing you really want to do, if you want to use your time efficiently, is sketch a graph. Now, the points. There's the wrong page. Okay, the points are 1, 3, and 8, 9. Okay. Well, you know, all I want to do is I want to mark 1 here and 1 here. Okay. I don't want to make a bunch of other marks. I don't need an accurate graph of this to answer the question. So the first thing I'm going to do is just slot down a couple of points. I think 1, 3 is about here. And if this is 3, then if I'm using equal scales, if this is 1, 8 out about here, and 9 is up about here. So here's a point 1, 3, and here's a point 8, 9. I don't want to have to make 30 marks and label them all. It's not necessary to represent the essence of this problem. Again, that's your decision, but you're going to take a lot of time doing something clerical when you can get to the essence. And on a test, I'll tell you if I want you to make a really accurate graph. Another thing you can, of course, have done, you say, well, 8's the biggest number I got out here, so I'm going to put 8 here. I'm going to divide that in half, and there's 4, I'm going to divide that in half. There's 2, and here's 1. It's really all you need. And up here, I've got 9. Well, I'm going to just go up to 8. Here's 8. Here's 4. Here's 2. Here's 1. Pretty well scale, pretty accurate scale. 2 is a little high, but that would be passive. And then it says transform by being moved 3 units in the vertical direction. Okay. Okay, so we move 3 units in the vertical direction. 3 units is like from here to here. That's 3 units. So I take an arrow here and move it up here. And I go, well, if I move 3 units in the vertical direction, I'm going to be out at 1, 6. So I could label that if I want. It's a little high. I didn't do it real great. There's my arrow, and there's an arrow of the same length that takes 8, 9 up to 8, 12. And now I ask, which moves further, or are the distances the same? So, what's your opinion? So, how many think the points move this point moves further than this? How many think this one moves further than this? How many think they move the same distance? Only one person voted. They both moved up 3 units, right? Well, probably want to read the solution and think about it. But that's all it takes to represent this on a piece of paper. Now on the test, maybe you want to be a little more careful, but you don't have to be more careful than necessary. It's one reason people go in for a 1-hour test and end up taking 3 hours. I don't put time limits on it. So if we want to be really meticulous, you go that long without food. Okay. Okay, there's another problem. It asks you to move 1 point 3 times as far. Okay, well, this is. Raised 3 units. They all move the same distance. Now, if I want to move 3 times as far from the x-axis. And it's, careful in the problems, I think. To state this is moved vertically 3 times as far. Well, if I move this point 3 times as far, this is how far it is. If I move that far again and that far again, then I've got a point 3 times as far. This is the distance of this point from the x-axis. If I move 3 times as far, I've got to move that distance, and then I've got to move that distance again. Now, if I want to represent how far it moved. Might be hard to read that, I think there's a whole lot of room, even though I was gonna write that. But this is how far each point moved. Now, did they move the same distance? How many would say they moved the same distance? Okay. Did this one move further than this one? Well, does this one move further than this one? Well, this arrow is bigger. This clearly moved further than this one. Okay. If this is out on an open field. And this distance here is 100 yards. And I ask you to move this distance. Fast. Well, if you're young and healthy, you can probably come pretty close to sprinting 200 yards. Okay. Ask me to sprint for 200 yards. I'll look like you're crazy, and I'll take off in a slow walk. Okay. Have to do a little better than that. Good sprint. Okay. If I then ask you to move this distance, and this distance here is 100 yards, you ain't going to sprint that far. Nobody can sprint that far. Some people can come pretty close, highly trained athletes, but nobody can do a full out sprint for half a mile, which is probably about what that would be. Okay. I mean, draw the pictures. Think about what you're seeing. And then if you don't understand, read the solution and do step by step what the solution dictates. And then come back a couple days later to a different set of problems. Try to work them without having to look at the solutions. When you get to where you can work these problems without looking at the solutions, you're pretty well ready to at least pass the test. And hopefully add that to everything else that you've learned to do in the homework and do real well in the test. So what we're seeing here is a vertical shift. And down here, we say Elephant math has a shorter way of saying that, but I like to say vertical stretch by a factor of 3. Factor means something that's multiplied by. Multiply these vertical distances by 3. reference back to the x-axis. That's what a vertical shift or vertical stretch versus vertical shift means. And people way too often confuse the two. And as a result, don't do what they need to do. So there's a function f of x. Very similar to the function we have on the paper here on the third page, about halfway down, a little above the halfway mark. And we want to do u of x equals a times f of x. Now, in the statement of the problem, I tell you that a equals -3, h equals -6, k equals -9. Different versions of the problem giving different expressions. So G is a f of x. That's -3 f of x, which is then -3 times 7x minus 3 over the square root of 2x plus 5. And that's going to be -21x plus 9 over the square root of 2x plus 5. Okay, that's very straightforward. We're just multiplying a by f of x. Replace a by -3, we get this. Replace f of x by the expression for f of x. There we have it. And then we just multiply the -3 through the numerator, and we have our final point. And of course, the algebra of that, it's still giving people a little bit of trouble. Okay. H of x equals f of x minus h. Well, h is -6. That's f of x minus -6. Which is f of x plus 6. What's f of x plus 6? Well, f of x is 7x minus 3 over 2x plus 5. We've replaced x by x plus 6. So we replace all these x's by x plus 6. And of course, you've heard me say that a bunch of times. Different functions. So we get this. Then, of course, we can do the arithmetic or the algebra, expanding and simplifying the numerator and denominator. And we get this. Now, if we had a graph of f of x, and of course, the problem doesn't address this, but say the graph of f of x looks something like this. Actually, the graph probably looks something like this. Okay. Probably doesn't go complete down either. Doesn't really matter what the graph looks like. Okay, maybe something like this. It's not a parabola. It's distorted. And over here, well, it's undefined. The next lesson, like -5 halves. So there's, So the point now is f of x minus -6. F of x plus 6. Shifts this graph 6 units to the right. Time to label that. I think we are out of time. If this is a graph of f of x, and the graph of this function doesn't quite look like this. Going to shift 6 units to the right. And 6 is going to be a little bigger than what I just drew there, but really have room. Okay, just demonstrating that that's what this transformation does in this graph, and I can always put a graph up there and ask you to do a given transformation. Okay. As you know how to do transformation at one point, which is developed pretty well in the problems that precede this, and you can do others. Now, the problem we just looked at, which the last one we have time to look at today. You have a list of like 7 or 8, I think it's 7 functions. Okay, you understand what to do here and understand what to do here. Then you pretty much understand what to do for all of them. But you should do it. Check yourself with the solution and work at it until you can always do it right. Okay. Now, again, don't rely too much on the solutions, because as I said, there's a glitch at the last minute yesterday before I could do the last proofreading. So I'd still have to do a proofreading, and I'll email an accurate copy. At least a more accurate copy. This is a beta version. Fairly expensive set of codes. Not difficult codes, but there's a lot of them, a lot of opportunities to make mistakes. I will never guarantee that everything's correct. But most of the calculations work pretty good. Use this as a guide. There is one assignment for next time on rational expressions. So I did that in the MDE class. Refer to that video. Send me questions if you have them. And go on. I decided simply at this stage it's more important to get some review because we have to have the test next week. Again, I'll accept it for a couple of days after spring break. But when I get it, at least the major is done before spring break. So spend some time on this and don't neglect your open math assignment.